first of all, let me say it's great to be back. I was traveling around the world. I spoke in Australia and New Zealand for the first time. In fact, when I spoke in Sydney, Australia, we sold out. We sold out the Opera House. You know, the famous iconic Opera House. Every time you see an advertisement talking about Australia, there it is in its full glory, the Opera House. Well, we sold it out. We had a sellout tour throughout New Zealand and Australia. But it's great to be back here in New York City, interacting with you, the listener. And so once again, in this hour, we're going to take your listener phone calls. Now, if you want to be part of the March of Science, then get to the telephones and give us a call. The hotline number is 612-564-8135. 612-564-8135. Give us a call, leave your name, call letters of the radio station you're listening to, if you're listening to one, and the city you're calling from, and then ask that question. Make that comment that you've always wanted to make but never had the chance. Here's a chance to do it and get on national radio as a consequence. Have your voice heard on almost 100 radio stations that carry Science Fantastic. And by the way, one question that I often got when I was touring is, well, why do we have to learn science anyway? It's so abstract, it's so hard. And I tell people that, well, ultimately, science is the origin of prosperity and wealth. Think of it, 100, 200 years ago, people didn't live very long. I mean, life expectancy for most of human history was about the age of 25. That's right. On average, you wouldn't live much beyond the age of 25 throughout most of human history. During the Roman Empire, for example, life expectancy rose a little bit, up to about 32. But it fell back again during the Dark Ages. And so life historically was cruel, short, and brutal. And so we have to realize that what life would look like without science. Well, once again, in this hour, we're going to take your listener phone calls. So give us a call, 612-564-8135 is the number to call, and you can have your thoughts heard on national radio on Science Fantastic with Professor Michio Kaku. And also go to my website, it's mkaku.org, mkaku.org, or go to my Facebook site at Michio Kaku. We're over 3 million fans now on Facebook. On Twitter now, we're up to 670,000 fans on Twitter. And so find out what all the excitement is about by going to my website, going to my Twitter account, or my Facebook account. And once again, go to mkaku.org, mkaku.org. Okay, well, let's now move right on and take your first listener phone call.
Hello, my name is Keith. I'm from Minneapolis. And I'm a fan of Walter Miller's book, Canticle for Leibowitz, that deals with life on Earth after a global nuclear war. Some humans have survived, but the world has been reduced to stone. In the book, the monks of Leibowitz preserve the surviving remnants of man's scientific knowledge until the world is again ready for it. After a global nuclear war, I'm wondering how long you think it would take for humans to build civilization back to the point of, say, building a functional electrical generator or a combustible engine, and what would be the process humanity would have to go through to get human civilization back to those technological achievements. Thank you.
Well, yes, I'm familiar with that science fiction series, and we have a negative example of what might happen. Look at the fall of the Roman Empire. During the height of the Roman Empire, in the centuries after the birth of Christ, we saw a blossoming of science and technology at tremendous human cost, of course. However, the Romans built an empire of roads and buildings and aqueducts and monuments and temples, an incredible legacy, a legacy of engineering and science. But around 400 AD or so, the whole thing collapsed. And how long did it take to get back up to speed again, it took about 1,000 years. A lot of that knowledge was lost, and of course the records were burned down. The Library at Alexandria was burned. Most of the knowledge of the Roman Empire vanished with the Roman Empire. For example, the Romans were able to build concrete using a formula that we still do not really understand. You can still visit the ruins of the Roman Empire 2,000 years later, and the buildings that they built are still relatively intact. However, because we simply do not know how to mix concrete very well, our buildings last maybe 50, maybe 80 years until they start to crumble. And so think about that. Even 2,000 years later, we're still trying to figure out how the Romans built such great concrete buildings. Now, you ask a different question. What happens today in the modern era if we have a nuclear war? How long would it take to reestablish civilization? Well, I think it would still take centuries. Of course, if a single microchip were to survive the nuclear holocaust, then of course we could then reestablish much of the technology almost instantly. The problem is not reestablishing the technology. That's not the problem. The problem is the social integration of science into society, because we degenerate into a bunch of barbarians. Now, if you want to know what society may look like after a nuclear war, just look at our ancient history, where we had tribalism, and for thousands of years, tens of thousands of years, we were in small little bands of maybe 100 people, each fighting to the death, fighting over limited resources. And you realize that human psychology hasn't changed much in 200 or so thousand years. In other words, even though we celebrate our monuments and our science and our technology and our rockets, even though we celebrate our achievements, we have to realize that the brain behind all of it hasn't really changed much in 100, 200,000 years. We still have the caveman brain, the cave woman brain of our ancestors. And so the problem is not technical, reestablishing civilization after nuclear war. The problem is social. How will we govern ourselves after a nuclear war? Personally, I think we could very easily degenerate back into tribes of maybe 100 people. And these tribes would war with each other over limited resources. And knowledge would be forgotten in this process or hoarded by a few. And that's what prevents the rise of civilization over the next several centuries after a nuclear war. The technology is there. We can reestablish the technology very quickly. The problem is social integration. What kind of tribalism are we going to degenerate into after a nuclear war? And something to think about. It took 1,000 years after the fall of the Roman Empire. I think it would still take a few hundred years because of the fact that we still have the caveman brain, the cave woman brain, and will degenerate back into tribalism after a nuclear war. Okay, let's move on now to the next listener phone call.
Hi, Michio Kaku. This is Kenneth, listening on GCN. I'd like to ask about the mathematics behind music. I understand that certain, the Fibonacci sequence and the golden ratio are associated with the quality of music. So, in a sense, if that is the case, that a lot of Beethoven and Mozart's work is based on like a Fibonacci sequence, wouldn't that apply to aliens as well? So if an alien living in another star system that has no human anatomy were listening to music, wouldn't he feel the same, appeal towards Beethoven that human beings do, since mathematics is actually the language of the universe itself? So wouldn't it make sense that, in not all cases is like art in the eye of the beholder? In many cases, wouldn't it be actually a mathematical thing?
Well, you ask a rather deep question that has stumped psychology and scientists for generations. And that question is there a universal aspect to art and music that appeals to not just us, but to animals and to aliens from outer space? First of all, why do animals make sounds anyway? Why do crickets chirp and why do birds sing? And the reason is, well, evolution. It's a sign of maturity and it's a sign of health and vigor that you can make these sounds with regularity. And it shows that it's an advertising call. That's why crickets crick and birds chirp, to attract mates. So scientists have actually analyzed the music of birds, believe it or not. We find that birds that are healthy, that have a clear vocal passage, that are free of parasites, make a very vigorous sound, which essentially advertises their health, advertises the fact that they're healthy, they're free of parasites, and they have a very clear voice. And that's very attractive to birds of the opposite sex. And scientists also found that the more complex the melodies of the birds, the more vigorous they were in terms of attracting mates. So in other words, it really does pay when you want to attract someone from the opposite sex to be able to hum a few bars and to sing with a very clear and pleasing voice. Now, you ask yet another question, not just art and appreciation and mating calls, but mathematics. Well, yes, it turns out that music has a mathematical basis to it, first worked out over 2,000 years ago by Pythagoras, the same guy who worked out the Pythagorean theorem for right triangles that we learned in school. That same Pythagoras also analyzed a lyre string. If I take a lyre string and I twang it, I get octaves that are half integers of the length of the lyre string. So you realize that the two ends of the lyre string are anchored and they don't move at all. Therefore, if you vibrate it, the vibrations are in half integral fractions of the length of the string. You have the principal octave and secondary octaves. And so when you look at music, it turns out there is a mathematics behind the music. So will aliens from outer space also like music? Well, we don't know, of course, but it's very possible that certain sequences like the Fibonacci numbers that you mentioned that are found in nature are also found in outer space. And one day when we make contact with aliens from outer space, well, music may be one way in which to communicate with them. I like to think of it this way. Take a dog, a cat, or a bat, or an animal, and if you could somehow breed them over millions of years to have large brains and to become intelligent, what would their intelligence look like? Well, a dog's intelligence, if you could breed an intelligent race of dogs, would be based on smells. It turns out that dogs don't use eyesight and other senses so much. They use hearing and smells. Their brain lives in a swirl, hundreds of swirling odors that circulate inside the brain of a dog. If you take a bat and were to somehow genetically engineer it so it became intelligent, sonar would be the way in which bats would communicate by echoes, by chirping and listening to the chirping's echoes as it reverberates. And so then you begin to realize that, my God, animals, if they become intelligent, may have a totally different frame of reference than humans. We use eyesight. We don't use smell so much. We don't use sound so much, but we use eyesight. But a lot of animals don't have eyes at all, and they would have a totally different way of communicating. But anyway, to answer your question, I think yes. I think aliens will have some kind of music because it does represent a regularity found in Mother Nature, and it also represents health. Now, scientists who've analyzed the mating calls of animals realize that animals that are healthy and symmetrical get more mates than animals that are not symmetrical. So symmetry also implies health, and so we find that in the animal kingdom, animals that are not symmetrical don't get mates because it's a signal of disease, injury, while animals that are symmetrical, it's a reflection of health. And so, in other words, one way to attract members of the opposite sex is to be healthy and to communicate in complex ways, like complex melodies. So maybe that's the origin of why people like Elvis Presley have such a magnetism when it comes to the opposite sex. Okay, let's move on now to the next listener phone call.
This is David Ferguson from College Station, Texas. My question is in regard to the digitized individual. So would AI also be included in that? So if you were talking to Einstein with all of his writings and history behind him, would AI be able to basically recreate his thought process to answer new questions that he has yet to answer? Thank you.
Well, the answer is yes. What you're talking about is a digitized person, that is a person who becomes immortal by having everything known about that person digitized and recreated in the form of a human being. And so in the future, when you go to the library and get a book about Winston Churchill, in the future, you'll actually talk to Winston Churchill. You'll talk to, let's say, a holographic image or a robot. And the robot or the holographic image will have all the memories, all the writings, everything that has been digitized and known about Winston Churchill. And then to smooth it out, in order to put in common sense and jokes and things like that, you'll probably have to put in artificial intelligence. Now, as you mentioned, well, I would love to have a conversation with Einstein. Someday, someone will digitize everything known about Einstein's writings and his personality, but to smooth it out, to put it together, to fill in the blanks, will require artificial intelligence. And that's, of course, when we start to tinker with somebody else's personality, perhaps not in an authentic way. That's a problem. However, in about 100 years or so, who knows for sure, the Connectome project will be finished, and I'll talk about that after the break. Once again, you are listening to Science Fantastic with Professor Michio Kaku. Give us a call at 612-564-8135 and ask that question and get on national radio. Once again, 612-564-8135. Digital immortality. Is it possible that one day we'll digitize everything known about us, our credit card transactions, our Instagram photographs, our website information, everything known about us, and will it require a little bit of artificial intelligence? And the answer is yes, because you don't want to be talking to a tape recorder. You want to be able to interact with that person, gossip with that person, and that would require common sense and a little bit of background, and that would require artificial intelligence. However, in 100 years' time or so, who knows for sure when, the Connectome project will be completed. Right now, we have, of course, the Human Genome Project, which is already entering the marketplace. Everyone is trying to get as much information about their bodies and genome as possible for health purposes and also to find out your origin. But beyond that, in about 100 years' time, we will map the entire human brain. Just about a month ago, it was announced that we mapped the entire brain of a fruit fly. That's right. They sliced patched up the brain of a fruit fly, reconnected all the neurons with a electron microscope, and bingo, 100,000 neurons were connected, and in principle, we can reconnect the brain of a fruit fly. Now, our brain is not 100,000 neurons. Our brain has 100 billion neurons, and as a consequence, it would take many, many decades, maybe a century, to have a connectome of the human brain. But when that happens, perhaps we'll be able to decipher the coding of the brain and then extract memories, your personality, your quirks. Everything known about you might be extracted once we have the connectome. But of course, we're far from that. We can only sequence the brains of animals, simple animals at the present time. But one day when we have the connectome project, literally you could live forever, or at least your soul, your information in your soul will live forever. Okay, let's move on now to the next listener phone call.
My name is Madeline Anderson, and I am calling from WGAW 1620 in College Station, Texas, and I would like to know how the sun formed.
Okay, well, that's a question that has haunted civilization for thousands of years. People worship the sun. They set their calendars to the sun. Mysticism and all sorts of sorcery were associated with the sun. But now we have modern astronomy. And with the Hubble Space Telescope, we can actually see stars in all phases of their life cycle. That's right. Within the range of the Hubble Space Telescope, we can see 100 billion galaxies. Each galaxy in turn has about 100 billion stars. And so that's 100 billion times 100 billion stars in the visible universe. Therefore, by analyzing the time sequence of these stars, we can then patch together the life cycle of stars, starting with a gigantic ball of gas about a light year across. Well, let's take a short commercial break, and after the break, we'll talk about where the sun came from and how the sun will eventually die. Well, before the break, we had a question about the life cycle of the sun. Where did the sun come from? And as I mentioned, we have actually a very good understanding of the sun. First of all, the sun started off as a ball of gas, perhaps a few trillion miles across. It was rotating very slowly, but gravity eventually began to collapse this slowly rotating ball of gas. And as it collapsed into a disk. The disk, the outer rims of the disk, eventually became the planets. And at the very center of the disk, most of the mass was concentrated into a ball of hydrogen. The temperature of the hydrogen began to rise as the ball of gas began to be squeezed. And as the temperature rose, eventually it hit, about 100 million degrees or so. At that point, fusion takes place. Protons slam into other protons of hydrogen, creating helium and energy via Einstein's famous equation, E equals mc squared. So E equals mc squared is not just a formula that we memorize for the hell of it. No, it is the secret of the stars. It's the reason why the universe lights up at night. It's the origin of all life on Earth. The energy of the sun comes from E equals mc squared, where m is the mass of hydrogen. E is the energy released when hydrogen fuses and turns into helium. Eventually, however, it exhausts its supply of hydrogen. We are halfway through that process. The sun is about 4.6 billion years old. In about 5 more billion years, it will use up its hydrogen and become a helium-burning star or a red giant. It'll expand, and at that point, it will eat up the Earth. And so if you understand how the sun was formed, you also begin to understand how the earth was formed and how the earth will eventually die. The earth will die when the sun uses up its hydrogen, expands and becomes a helium-burning star, a red giant, and 5 billion years from now, we will have the last nice day. The sky will be on fire, the mountains will melt, the oceans will boil, and we will go back into the sun. So the Bible says, from dust to dust, ashes to ashes. Physicists say, from stardust we came, and stardust we will return. And eventually the sun will exhaust its energy supply of helium and become a small white dwarf star, which will eventually cool down to the point where there's nothing left to burn, and it'll become basically a black dwarf star, a piece of nuclear waste floating in outer space. So the poets ask the question, will the world end in fire or ice? We know the answer to that. The earth will end in fire when it's eaten up by the sun. The sun itself will end in ice when it uses up its nuclear fuel. The galaxy, by the way, our Milky Way galaxy, will end in fire when it collides with the neighboring galaxy Andromeda, and the universe itself will die in ice, we think, when it cools down to near absolute zero. At that point, by the way, trillions upon trillions of years from now, when the universe gets awfully cold and the universe itself dies, I personally think that we'll be advanced enough then to leave the universe. We'll create an interdimensional lifeboat, leave the universe, go to a younger universe, and perhaps mess that one up as well. Okay, let's move on now to the next listener phone call.
Dr. Kaku, my name is Ben. I'm calling from Phoenix. I'm listening on my TuneIn app. I believe it is WNTCAN is the call numbers. Quick question. With, in your opinion, I guess, along with Professor deGrasse Tyson there, does the privatization and commercialization of this modern space race help to break down the barriers, such as the black budget, black projects, that separate technology from you and I? And does Dr. deGrasse Tyson think that this can ultimately help mankind grow as a species and help to break down those barriers? Because ultimately we can't even fathom what it would take to become a type 1 civilization, but didn't know if he had any thoughts on that.
First of all, about Dr. Neil Tyson, we actually had him on Science Fantastic just a few weeks ago, talking about his latest book, Accessory to War, and it brings into sharp focus the relationship between the public sector and the private sector. And then you ask yet another question about whether or not we're going to make it to a type 1 civilization. So let's try to break it down. Neil and I both agree that we have to be realistic when it comes to the history of science. That yes, science and warfare have been linked ever since we picked up the first bow and arrow, and we use it to find game, but also we use the bow and arrow to fight other humans. And so we have to realize that science, technology can be used either for good or for evil, because science is a double-edged sword. It can either cut against ignorance, poverty, disease, or it can cut against people. It all depends upon the democratic control of that sword of technology. Now, you also allude to the fact that the private sector is coming into the space race. I think in general that's not a bad thing, because of course governments do projects that have a lot of cost overruns, and they have to worry about public relations and things like that, while private corporations can cut a few corners and do things faster. But of course, because they cut a few corners, we have to worry about safety as well. But the fact that SpaceX, the fact that Elon Musk Blue Origins, the fact that Virgin Galactic, the fact that all these companies are being formed is reinvigorating the exploration of outer space. The cost of going to outer space has been dropping like a rock because of this, making it possible to have space tourism, making it possible that one day mom and dad might be able to go into outer space. And so I think that in general it's a good thing as long as it doesn't get out of hand, the fact that the private sector is engaged with outer space. And we're going back to the moon as a consequence. The government, realizing how costly it is to go back to the moon, has basically not done anything about the moon for the past 50 years. But now Jeff Bezos of Blue Origins and Amazon, Elon Musk of SpaceX are creating their own moon rockets with not taxpayers' money, but with their own funds. They are opening up their checkbooks. Elon Musk has the Falcon Heavy and the BFR rocket, and Jeff Bezos of Amazon and Blue Origins has his new Armstrong rockets. All these rockets are capable of reaching the moon. And so we don't have to wait for governments, which are very slow and cautious, to take us back to the moon and one day perhaps even to Mars. Now, you ask yet another question, and that is, will all this affect our march toward a Type 1 civilization? Well, let me try to break this down once again. We are a Type 0 civilization. A Type 1 civilization is about 100 years more advanced than us, and they use all the energy available to them that comes from the sun. They control the weather, for example. A Type 2 civilization controls the energy of a star. A Type 3 civilization controls the energy output of a galaxy, like Star Wars. Star Trek would be more like a Type 2 civilization, which has colonized a few planets, and you can play with stars, but we are a Type 0 civilization. Now, will all this affect our march toward Type 1? And the answer is, I don't think so. I think it's inevitable, unless we blow ourselves up, it's inevitable that we will become a Type 1 civilization. We see the beginnings of a Type 1 civilization even as we speak. What is the Internet? The Internet is the beginning of the first Type 1 telephone system, the first Type 1 technology to fall into this century. And what language will this Type 1 civilization speak? Already on the Internet, English and Mandarin Chinese are the two most popular languages on the Internet. And so we're already seeing the beginning of a Type 1 civilization. And the fact that private enterprise is helping public enterprises begin the process of conquering outer space, I think will help, but not basically accelerate the march toward a Type 1 civilization. Okay, well, let's move on now to the next listener phone call.
Hi, my name is Lance Rome, calling from Green Bay, Wisconsin. I listen to you off of your website. My question is more of just a crazy thought. With all this crazy weather that's been going on with hurricanes and whatever all around the world, what if it's some big secret company trying to make the world a Type 1 civilization, and they're trying to control all the weather, and that's why they're getting all these hurricanes and horrible weather across the world. So yeah, what are your thoughts on that, just for fun? Thank you.
Okay, well, definitely the weather seems to be very different. Even several years ago, the former President George W. Bush, a conservative, said that something strange is happening to the weather. And so we're talking about the fact that farmers notice that the weather is changing, because after all, summers are about a week longer than normal on average. And if you're a farmer, you have to know exactly when summer and fall and winter begin in order to coordinate the planting season. And also, I just finished a national book tour. My book is called The Future of Humanity, and I've had a number of questions that were given to me, and I'll try to answer another one of these questions. The question that sometimes I get is, why didn't Stephen Hawking, the great physicist, ever win the Nobel Prize in Physics? Well, if you think about it, that is ironic, because many lesser-known physicists who have done less spectacular work, they've won the Nobel Prize. So how come the Nobel Prize eluded Stephen Hawking, a physicist so famous that he's going to be buried in the Westminster Abbey? The Westminster Abbey in London is the most sacred church in all of British Christendom. Isaac Newton is buried there, not to mention many kings and queens of England. and including Stephen Hawking. So the question is, why didn't he ever win the Nobel Prize? Well, the answer is quite simple. The Nobel Prize is given for things that have been tested in the laboratory. Well, Stephen Hawking's main contribution is untested, and that is Hawking radiation. You see, black holes are black because they absorb all light. Nothing can escape. They're like the ultimate Roche Motel. Everything checks in, nothing checks out. However, Hawking showed, and this is his great contribution, that when you add the quantum theory of atoms to black holes, you find that black holes are not really black at all. They're gray. They emit a very faint radiation called Hawking radiation. That's why he didn't win the Nobel Prize. This is a great discovery because it was the first major application of the quantum theory, that is a theory of atoms, to the theory of Einstein, a theory of gravity. These two theories usually hate each other, but Stephen Hawking showed that these two theories create a new effect, Hawking radiation. But it's too faint. It's too faint to be observed in the laboratory. So we physicists believe it exists. It's out there, Hawking radiation, but the proof eludes us, and that's why Stephen never won the Nobel Prize. Okay, well, let's move right along now to your listener phone calls. Give us a call at 612-564-8135. Let's take the first listener phone call.
Hi, I'm Danny. I'm calling from Florida. My question is about your book, the Terraforming Mars part. Now, the only two examples I know about it are the Superman movie, where like everybody was floating up in the ground and everything, and I think there was another movie where the guy survives on Mars, which he like basically made like a small little greenhouse and grew vegetables and stuff. I know the Superman movie wouldn't be like that. So if we were to do like a little bubble greenhouse sort of deal, and let's say we wanted, the target would be half of Mars, not all of it, just half of Mars. In a realistic sense, how long would that take to happen? Thank you.
Well, you ask a question that a lot of NASA engineers are asking themselves right now. And that is, well, if you saw the movie The Martian, starring Matt Damon, he was left stranded on Mars with no backup, no supplies, and he had to grow his own food and sustain himself on the red planet. So one of the first things he had to do was find a way to get oxygen through a chemical reaction. Once you got that, then of course you have to get fertilizer for food, and he used his own waste products, for fertilizer. And then he started to grow plants on Mars because you had the carbon dioxide atmosphere. It's cold, but you can heat up the temperature using solar panels and agriculture. He was then the first one to create agriculture on Mars. Now in the future, we'll do it using genetically modified algae. The carbon dioxide atmosphere is ideal to grow organisms. Plant organisms love carbon dioxide. And so it may be possible in the future to create a self-sustaining aquafarm, or a farm of genetically modified organisms on the surface of Mars. That's one industry that you definitely want to get off the ground. Another industry is mining, because frozen water can be unfrozen, and that creates drinking water once you purify it. And you can separate it out into hydrogen and oxygen. So these are the two reasons why you can use A, hydrogen for rocket fuel, and B, oxygen for breathing. So water would be the first major substance to be mined on the surface of Mars. This is beginning the process of terraforming Mars. So it's going to be very difficult. No one's going to terraform Mars immediately. The first settlements will just tinker with the mechanics of terraforming Mars, but the actual terraforming of the planet itself will take much longer. Now, how do you jumpstart it? If you can raise the temperature of Mars by 6 degrees, you will have a runaway greenhouse effect. How do you do that? You inject methane gas into the atmosphere of Mars. The methane gas captures sunlight, creates a greenhouse effect, which captures more carbon dioxide, and so you have a runaway greenhouse effect. Well, before the break, we also had a call about terraforming Mars, and he also mentioned Superman. So let me give you a historical link between Mars and Superman. Near the turn of the century, Edgar Rice Burroughs wrote the Tarzan series, for which he was famous, but he also wrote the John Carter of Mars series as part of pulp fiction back in the 1920s. Back then, he realized that Mars had a lower gravitational field than the Earth, so he said that if an Earthling were to go to Mars somehow, he would become somebody with superhuman powers. He'd be able to leap tall buildings in a single bound. He'd be faster than a speeding bullet. So, Edgar Rice Burroughs said that this man on Mars, John Carter, would have the power of a Superman. Well, what happened was nothing happened until World War II comes along and people want a hero. And that's the origin of Action Comics and Superman. And in the very first issue of Superman, the very first issue, it says very plainly that anyone from another planet landing on the Earth would have superhuman powers because of the low gravity, precisely echoing the words of Edgar Rice Burroughs, creator of Tarzan, and John Carter of Mars. So in other words, the link between Mars and Superman is that Superman is in some sense a son of John Carter, a creation of the man who created Tarzan. Okay, well, let's move right on to the next listener phone call.
I'd like to propose at least one question. If the background microwave radiation from the Big Bang heats up the relative vacuum of deep space by 2.74 degrees Kelvin, then how can people like Dr. Lee Howe at Harvard, who were trying to reach absolute zero, completely evacuate the BMR from an environment so that the thermometer doesn't reach just 2.74 degrees Kelvin, but actually goes down to absolute zero? I found your presentation delightful on the future of humanity.
Okay, well, first of all, let's break down your question. It turns out that in outer space, there is an echo of the Big Bang itself. Believe it or not, you can calculate that the Big Bang was very hot, but in 13.8 billion years, it cooled down. So the temperature of the background radiation left over, the aftermath of the Big Bang, has a temperature today of 2.7 degrees above absolute zero. So children sometimes ask the question, Mommy, Daddy, how cold is outer space? Well, we know the answer, 2.7 degrees. Why? That's the temperature of the Big Bang today. Anything that hot back then could not go to zero today. We see residual radiation from the Big Bang at 2.7 degrees above absolute zero. But on the Earth, you can create in the laboratory temperatures below 2.7 degrees centigrade. Now, remember, that's a temperature of outer space. But on the Earth, it's possible to take out energy from a container of energy and drop the temperature below 2.7 degrees centigrade. And that resolves the paradox. And that is, if the temperature of outer space is 2.7 degrees, how can on the Earth you can get a chamber a small chamber where the temperature inside is below 2.7 degrees centigrade. There's no contradiction whatsoever. And by the way, you can pick up this radiation on your transistor radio. If you turn your frequency on a transistor radio randomly, you get static. Believe it or not, most of that static comes from Jupiter. Jupiter is quite noisy in the radio spectrum, quite radioactive, but you can also pick up the Big Bang itself. This is amazing that even a simple transistor radio can pick up residual leftover radiation from the creation of the universe itself. Absolutely amazing. Okay, let's move on to the next listener phone call.
Hello, my name is Charles Davis. I'm not listening to a radio station. I actually got your information off the internet. But I have a question for you. Was there ever a reverse law to the theory of light written by anyone, including Einstein, never published? If so, what would the implications of that be? And would that actually be I guess you could say, a link to relativity and quantum theory possible? Thank you.
Well, I think what you're asking is there a reverse form of light? I think that's what you said. In other words, anti-light or dark light. That light from a flashlight emits radiation, but a dark flashlight would absorb radiation, and blackness would come out rather than light. Well, the short answer is no, but let me explain why. First of all, there is something called antimatter, the opposite of matter, which is different charge. So the electron has negative charge. We learned that in elementary school. But the anti-electron, the positron, has positive charge. So antimatter has the opposite charge of ordinary matter. Now, light, however, has no charge at all. It's chargeless. And anti-light is light. So that explains, first of all, the mystery of black light. There is no such thing, because light and anti-light are the same thing. You can also answer the question about anti-gravity. Anti-gravity is gravity. That is, the antiparticle of the graviton is a graviton. The antiparticle is the photon of light, is the photon of light. And therefore, reverse light or black light is not possible. However, recently, physicists were quite amazed that the universe itself is accelerating due to dark energy. Now, this is repulsive. Dark energy repels galaxies, and so it is a form of anti-gravity, which is amazing. There is a form of anti-gravity. However, what's the catch? The catch is it's extremely small. So small, you cannot make hoverboards or anti-gravity rockets out of it. Sorry about that. It is extremely tiny, but we do think on a scale of galaxies now, it is literally pushing the galaxies apart, cooling it down, and one day we may hit absolute zero or near absolute zero as a consequence of dark energy. Okay, let's move on to the next listener phone call.
Hi, this is Sean Markley from Shorewood, Illinois. My question is, as we become a level 1 or level 2 society on the Kardashev scale, which scenario becomes more plausible? Number one, us wormholing to other planets in the Goldilocks zone and search in our own universe for the continuity of the species, or number two, us wormholing into the past in an alternate universe to transfer folks into the alternate universe, if you will, for the continuity of the species. Appreciate any help on the answer, and thanks, and have a great day.
Okay, well, you asked a question about the Kardashev scale, which I write about. Kardashev was a Russian astrophysicist who wanted to catalog intelligent civilizations in outer space. A Type 1 civilization consumes the energy of a planet, like Buck Rogers. They control the weather. They can control earthquakes and volcanoes. Anything planetary they can control. Type 2 is stellar. They control the stars. They control the energy output of the star and nearby planets, like the Federation of Planets. The Federation of Planets in Star Trek would be a type 2 civilization. Type 3 is galactic. Well, before the break, we had another question that came in about the Kardashev scale and where we might take a wormhole to. Well, the Kardashev scale talks about civilizations centuries, millennia more advanced than us. A type 1 civilization can control planetary power. They control the weather. They can mine the oceans. Type 2 has stellar power. They control the power output of an entire star. They've colonized all the nearby planets. And type 3 is galactic. They control the power of black holes, and they roam across the galactic space lanes. Now, believe it or not, we can actually calculate when we will attain these incredible abilities. First of all, we know the energy output of a type 1 civilization, and so we are about 100 years or so away from becoming type 1. In other words, by 2100, we will become planetary with the ability to, for example, control the weather. In a few thousand years, we'll be type 2, the ability to control the power output of an entire star, like in Star Trek. Type 3 is galactic, the power to manipulate black holes to roam the galactic space lanes. And that depends on whether or not you can get hyperdrive. So that may be, who knows, maybe thousands to 100,000 years more advanced than us. Now, the question that came in is, when are we going to get wormholes? And where are we going to go in space or time with a wormhole? Wormholes are shortcuts. They are allowed by Einstein's theory. In fact, Einstein himself in 1935 was the first one to find a wormhole solution of his own equations. A wormhole is a shortcut, like the looking glass of Alice. A shortcut that allows you to go from one point of space or time and another point of space or time. Now, when can we have these, and on what scale are we talking about? Well, as you can see, a wormhole has the energy of a black hole. Therefore, almost by definition, we're talking about type 3. A type 3 civilization that can roam the galactic space lanes, has access to galactic energy, and has the power of a black hole. And that is the power to rip the fabric of space and time itself. Now, where are they going to go? Well, one point is to go to other galaxies and other star systems and other sectors of the galaxy itself. So perhaps Star Wars takes place in such a time, thousands of years more advanced than us. But what about going backwards in time? Well, that gets a little bit more dicey. Stephen Hawking, for example, admitted that it may be possible to create a wormhole to go into the future or into another point in space. Well, before the break, we had a call about the Kardashev scale of advanced civilizations and when we're going to be able to create wormholes. Well, wormholes are gateways through space and time made possible through energy scales of a black hole, meaning that we're probably talking about type 3. A galactic civilization capable of harnessing the power of dying stars and black holes to drill a hole through space and time. These are called wormholes, first pioneered by Albert Einstein himself in 1935 in a famous paper that he wrote with one of his students, Nathan Rosen. And then the question is, can you go forwards in space, like in a spaceship, or backwards in time? Well, Stephen Hawking had a point of view on this. He thought that wormholes to another point in space may be possible. The problem is graviton radiation. Gravitons are particles of light, and if you have enough gravitons, they can become quite dangerous and quite radioactive, and you can blow up the machine. So a wormhole machine may, in some sense, become unstable. Well, Hawking thought that maybe, just maybe, a wormhole machine taking you to a distant point in the galaxy was possible, that it was possible to control the graviton radiation as you entered the wormhole machine. But, he thought, to go backwards into the past, if you do the calculation, it turns out the buildup of graviton radiation blows up. And so maybe the machine explodes as you try to go to the past. Well, I've looked at that calculation, and I'm not convinced. First of all, how do you get the fact that the machine blows up when you go into the past in a wormhole? Because a light beam that falls in the wormhole winds up in the past, and then naturally goes to the present and goes into the wormhole a second time, and a third time, and a fourth time. That's why it blows up, because it goes through the wormholes an infinite number of times. But you see, I don't believe in that. I think you can only go through the wormhole basically once, not an infinite number of times, and so there's no contradiction with graviton radiation. Graviton radiation could in fact be finite. Now, why do I believe that you can only go maybe once through the wormhole? Because it depends on how you view going backwards in time. I personally think that the universe splits in half. The timeline forks into two rivers. One river takes you through a normal sequence of time, and the other river splits off, forks in the river of time, and that simply creates a new branch of a timeline. So all the paradoxes of time travel are resolved, and there are no infinities, no explosions or blowing up of graviton radiation. And so, in other words, time travel just might be possible. I'm not saying it is, because of course the calculation requires going to a higher mathematics called string theory, which is so advanced that we cannot answer the question yet. But in string theory, it's a quantum theory, time splits. And if time splits and you go backwards in time, you do not change your own past, which would create a paradox. You change somebody else's past, who looks like you, has the same mannerisms, but is your carbon copy. And so you've basically changed the fate of a parallel universe, but not your own. Sorry about that. And that resolves all the paradoxes of time travel. With a new outlook, you can read any time travel novel and resolve every paradox if you simply assume that the universe forks into two roads every time you go backwards in time. Okay, let's move right along to the next listener phone call. Well, before the break, we had a question, and that is, the universe we now know is much stranger than we previously thought. It is basically made out of dark energy, which is blowing the universe apart, and dark matter, which holds the galaxy together. Both are invisible, and both have led to Nobel Prizes. So the question is, if dark matter is dark and can hide things, could it basically hide a parallel universe? Well, probably no. However, it does raise some very intriguing questions. First of all, how do we even know there's dark matter out there? By looking at Newton's law of gravity, we know that the galaxy spins, but it spins 10 times too fast. If you take a look at Newton's laws of spin and calculate the centrifugal force of a galaxy spinning very rapidly, you find that it should fly apart. Therefore, something is keeping the galaxies together, even if Newton says they are flying so fast they should fly apart. And that's dark matter. So we use gravity to indirectly prove the existence of dark matter. Now, then the caller asked another question. If dark matter is invisible, is it possible that it's concealing something, like maybe another parallel universe? And the answer to that is probably no, because a parallel universe would have a lot of gravity. And gravity is how we even prove the existence of dark matter to begin with, because dark matter is invisible. Therefore, we see no presence of a parallel universe hiding inside the dark matter. However, there have been some surprises just in the last few years. One surprise announced just a few weeks ago was the fact that we can now have galaxies that are totally made out of dark matter, or galaxies totally made out of ordinary matter without the other. We used to think that dark matter and ordinary matter had to come together. But now we find that you can have ordinary galaxies with ordinary matter without that much dark matter at all, and vice versa. And so we're now realizing that the universe is a lot more mysterious than we previously thought. I should mention, however, that the leading candidate for dark matter is that it's a higher vibration of the string. We are the lowest octave of the string, but there are higher vibrations. The photon has a higher vibration. Its partner is called the photino, or little photon for short. And we think that is the leading candidate for what dark matter is made of. However, the question is more sophisticated than you realize, because in inflation theory, which is also a version of the Big Bang theory, inflation happens all the time at different points in the universe. So in some principle, it's possible to have universes inside universes, universes budding off other universes like a soap bubble budding off other soap bubbles. And so then it's not so surprising if you can get a universe hiding inside dark matter. Okay, well, let's move on to the next listener phone call.
Richard Kelleher, I'm from Phoenix, Arizona, and my question is, I just read that the longest recorded electrical pulses from a dead brain were 10 days. How long does a brain consciousness last after death?
Well, you ask a very important question, a question, of course, that is a subject of not just doctors, but also ethicists, because the question is, when the brain dies, but the body survives, are you really dead at all? Well, first of all, it's usually considered that in a period of 4 to 6 minutes, brain tissues start to die because of lack of oxygen. And by the time 8 minutes have gone by, you are most likely suffering from a version of brain death. That is, neurons start to die. And after that, you are probably clinically brain dead. In other words, the EEG, the electroencephalograph, picks up no evidence of electrical activity, even though the body may still be intact. And this, of course, raises many ethical questions. Sometimes people in a coma, like, for example, because of illness or a car accident, could be brain dead, but their body is still alive. And then the question is it possible, therefore, they could be revived after being brain dead? And you ask an even different question. What happens under certain rare circumstances, like, for example, when the body is cold, the body can survive much longer in a state of suspended animation. So let's try to break it down really quick. And that is, medical ethicists are still debating after the case of Ms. Shivo, who was brain dead, but the relatives clung to the possibility that she could be revived, even though most doctors believe that there was no chance of her coming back because there was simply too much damage to brain tissue. Now, it turns out that some people in comas do come out. However, they are not totally brain dead. If you are totally brain dead with no electrical activity, chances are you're not going to be able to be brought back. However, this is an area which is very fuzzy because, of course, it all depends on how you define brain dead. And if somebody, for example, falls in a lake, in a frozen lake, then it's possible the person could survive much longer because of the cold, which stops the degeneration of brain activity. So this is still a frontier question. Well, unfortunately, that's it for Science Fantastic. Once again, every week on Science Fantastic, you can explore the cutting edge of science with me by calling 612-564-8135. Leave your name, call letters of the radio station you're listening to, and the city you're calling from, and bingo, you might get on Science Fantastic.
How would you like to hit the range tomorrow with a brand new gun? Because the United States Concealed Carry Association wants to give you a free gun right now. That's right, completely free. The USCCA is here to give every responsibly armed American the education, training, legal, and financial protection they need. And today, they're giving you not one, but 4 free chances to win $1,000. Simply text GCN to 87222 to get entered now, and you'll get 4 free chances to win $1,000 for any gun you want. Text GCN to 87222 and get entered today. But remember, these free guns won't be around forever, and you can't win if you don't enter. So don't miss out. Just text GCN to 87222